This is lesson 3.3, Limits and Vertical Asymptotes. In this lesson, we are going to look at another key concept in calculus, vertical asymptotes, and how they relate to limits. These are concepts that you should have seen in other math courses, but we're going to expand on them from a calculus perspective. Understanding these will help you analyze the behavior of functions even further than we've already been doing, and this is going to lead us into looking at rational functions and why the derivative of rational functions is the way it is. So imagine you're driving down a road and suddenly it turns into a steep hill that becomes almost vertical. No matter how you try, you can't keep going. You either slide back or maybe you put on a rocket pack and shoot up to infinity. This is exactly what happens in math, minus the rocket pack, when a function approaches a vertical asymptote. We're going to explore this today, and we're going to start by looking at some examples. So a vertical asymptote is really just a boundary that shows where the function is not defined, or DNE does not exist. So if we were to look at this function f at x is equal to 1 over x squared, and if we were to graph it on Desmos, so I've gone ahead and I've done that, this is what this is going to look like. And if we think about what's happening here, so when can 1 over x squared not exist? When does this not exist? Well, 1 over x squared cannot exist whenever x is equal to 0. So x cannot be equal to 0, and the reason that x cannot be equal to 0 is because we can't divide by 0. Remember, we can't divide by 0. There it does not exist, or it's undefined. So we would say that the limit here does not exist when x equals 0. But let's think about what's happening as x gets closer and closer to 0. So as we approach x from the left-hand side, so this is our limit as x is approaching 0 from the left-hand side, what do we notice? Well, we can see that it starts, my y value is starting to increase, but it's getting closer and closer and closer to 0, but it is never going to get there. And this limit actually starts to approach positive infinity. Let's take a look at it. So that's our left-hand side. Let's take a look at what's happening from the right-hand side as we get closer and closer to 0 from the right-hand side. Again, this limit is getting higher and higher and higher. The closer we get to 0 in the x values, the closer to positive infinity my y values get. So as x approaches 0 from the right-hand side, we are also approaching positive infinity. So what can we say is happening here? Well, we can say that both sides get bigger and bigger in the positive direction. So both sides get bigger and bigger, and really big actually, so bigger and bigger in the positive direction. In the positive direction of y. And so we would say then that the limit as x approaches 0 of 1 over x squared is going to be equal to positive infinity. It's going to be approaching that positive infinity from both sides. So even though the limit doesn't exist, so if we take a look here, so even though the limit doesn't exist as x approaches 0, we could describe the behavior at the asymptote using our notation that the limit, this right here, the limit as x approaches 0 of f at x is equal to infinity or positive infinity if you wanted to think of it that way. We can test this by looking at what happens as x approaches 0 from both sides. And now, I know we've looked at it graphically, but now let's look at it numerically using our left-hand side, right-hand side. So, if I have my left-hand side, so my limit as x approaches 0 from the left-hand side, let's just choose a number. as we're getting closer and closer and closer and closer to 0. So I'm going to say let's choose negative 0.01, and that's going to be squared. So again, negative 0.01 is the value that I chose. Well, that's going to give me 1 over 0.0001. And if I divide that out, well, that's going to give me 10,000. Well, what do we notice here? That this is starting to get really big. So this is getting big in the positive direction. Getting big in positive direction. In fact, it's going to get so big that it is eventually going to equal positive infinity. Now let's look at what's happening on the right-hand side. So my limit as x approaches 0 from the right-hand side of 1 over x squared. Now, what value am I going to use? Well, this time I'm going to use positive 0.01, just to keep things even on both sides. So I have 0.01 squared. Well, again, that gives me 1 over 0.0001, or 10,000. This side is also getting really big. So also getting big, or really big, also getting big. In fact, it's also going to get so big in the positive direction that it is also going to approach positive infinity. Now let's think about 1 over x. Why would this not apply when f at x equals 1 over x? How could we use limits to describe the behavior at its asymptotes? Well, we need to think about when does 1 over x not exist. So when does 1 over x not exist? Well, it doesn't exist when x equals 0. So we're going to lean into this and we're going to find out what's happening at x equals 0. So the limit as x approaches 0 of 1 over x, and again we're going to break this down into our left-hand side and our right-hand side. So on the left-hand side of this one, I have the limit as x approaches 0 from the negative side. This will be 1 over some number. And again, let's just choose that negative 0.01. Pretty close to 0 from the left-hand side, but not quite there. So now what happens if I have 1 over negative 0.1? Well, this is going to equal negative 100. What if I added a couple more, zeros in there? So what if I had 1 over negative 0.001? Well, that equals negative 1,000. What if I have 1 over negative 0.0001? Well, that equals negative 10,000. So what's happening to our limit as we get closer and closer to 0? It's getting bigger in the negative direction, so bigger in the negative direction, which means that it's approaching negative infinity. So we would say that the limit as x approaches 0 from the left-hand side of 1 over x is going to approach or equal negative infinity. Now let's do the same thing with the right-hand side. So on my right-hand side, my limit as x approaches 0 from the right-hand side, let's use the same values, only this time they're positive. So we have 0.01. Well, that's going to equal positive 100. What if I start getting closer and closer? So 1 over 0.001. Well, that equals 1,000. What about 1 over 0.0001? Well, if you guessed 10,000, you would have been right. And we can see now that this is getting bigger in the positive direction. Can I squeeze that in there? Bigger in the positive direction. So that means that my limit as x approaches 0 from the right-hand side of 1 over x is going to be equal to positive infinity. So if we were to graph this, what would this look like? So let's just do this up here. What would this look like? So I know as I'm approaching from the negative side. So as I'm approaching 0 from the negative side, my values are approaching negative infinity. As I'm approaching 0 from the positive side, though, my values are approaching positive infinity. So what does this mean in general for asymptotes? Well, if there is a one-sided infinite limit, then x equals a is a vertical asymptote. And we would write that by saying the limit as x approaches a from either direction of f at x will equal positive or negative infinity. It will approach positive or negative infinity. So let's look at an actual example of what a function would look like. So here's the rational function, x over x squared minus x minus 6. And we're being asked to determine the vertical asymptotes, describe the behavior at the asymptotes using limits, and sketch the graph near those asymptotes. So let's start with the first part, and let's determine the vertical asymptote. So determine the VA. So what do we need to do to be able to do that? Well, just as a reminder, we are going to factor the denominator as needed. So factor the denominator as needed. We are going to eliminate any terms from the top and the bottom. So eliminate any terms from the top and bottom. That should help eliminate our problem of dividing by 0. And then we need to make each term or each bracket equal to 0. So make each factor equals 0. And these will be our vertical asymptotes. These are the vertical asymptotes. Okay, so we have y equals x over x squared minus x minus 6. So we need to factor the bottom of this. So x squared minus x x squared minus x minus 6. So we need to, you can factor this however you want. So I'm going to say if I have that, my two factors that multiply to be negative, okay, let's start again. So we need to factor the bottom of this, which means we are looking to find the factors that multiply to be negative 6 and add to be negative 1. So what two numbers do that? Well, the two numbers that do that are negative 3 and positive 2. So my factors for this are going to be negative 3 and positive 2. So let's go ahead and factor that out. So y equals x over x minus 3, x plus 2. So now I'm going to set each one of those equal to 0. So x minus 3 equals 0, so x equals positive 3, and x plus 2 equals 0, so x equals negative 2. These are going to be the locations of my vertical asymptotes. So we're going to use these limits to determine what's happening to the function as x approaches each vertical asymptote, and we're going to use the left-hand side, right-hand side test. Okay, so we know where our two vertical asymptotes are at x equals 3 and x equals negative 2. We're going to use limits to determine what's happening to the function as x approaches each vertical asymptote. And we're going to use the left-hand side and right-hand side test in order to be able to figure that out. I've added an extra page here so that I'm not, squishing everything together. So let's take a look at what's happening to our vertical asymptote when x equals negative 2. So let's start with the vertical asymptote where x equals negative 2. So the limit as x approaches to -2, we know is going to be x over our factored out form, x minus 3, x plus 2. So now let's look at this as it approaches from the left-hand side and from the right-hand side. So the limit as this approaches, as x approaches -2 from the left-hand side of x over x minus 3x plus 2. Let's pick a value that's really close to -2 from that left-hand side, and let's use -2.01. So again, we're just going to sub in. So my x value here is -2, and on the bottom I have -2 minus 3 times -2.01 plus 2. So we get -2 over 0.05, which gives me a limit here of -40. We can see that if we kept making this number closer and closer to -2, we are going to get closer and closer to -infinity. Now let's do the same thing and let's look at the right-hand side. So my limit as x approaches -2 from the right-hand side of x over x minus 3x plus 2. We're going to substitute our -2 in for our x and then let's use -1.99, so just to the right-hand side of -2. So we get -2 over -2 minus 3, -1.99 plus 2. That gives me -2 over -5 times 0.01. So that gives me +40. So I think we can see if we continued to take this number closer and closer to -2 from the right-hand side, we are going to get +infinity. That's where we're approaching. So what does this mean on our graph? So let's just pop down here and let's just start to graph this, because ultimately that is what we're being asked to do. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, so I know that I have an asymptote at -2. So let's get our asymptote in there at -2. And this is telling me that as we're approaching -2 from the left-hand side, my function is going to be approaching -infinity. As it's approaching it from the right-hand side, however, so as it's coming at it from this direction, from the right-hand side, it is going to be approaching +infinity. So now let's do the same thing for our vertical asymptote at x equals 3. So let's just get that on there. So there's our vertical asymptote at x equals 3. And now let's pop up here and do some math. So we're going to do the same thing. We're going to come at it from the left-hand side and the right-hand side. So left-hand side for this one, we have the limit as x approaches 3 from the left-hand side. I'm going to use 2.99. That's pretty close. So we have 3 over 2.99 minus 3, 3 plus 2. That gives me 3 over -0.01 times 5, which gives me a value of -60. So we can see as we're approaching from this left-hand side, if we were to continue to get our numbers closer and closer to 3, we are approaching -infinity. Now let's look at our right-hand side. So on the right-hand side, the limit as x approaches 3 from the right-hand side, let's use 3.01. So 3 over 3.01 minus 3, 3 plus 2 gives us 3 over 0.01 times 5. So that gives us positive 60. Again, if we were to continue to get closer and closer and closer to positive 3 from the right-hand side, we can see that this value is going to get closer and closer to positive infinity. So how does that translate to our graph? Well, as we are approaching from this side to 3, as we're approaching from our left-hand side, then that's telling me that this is going to be approaching negative infinity. It's getting more and more negative. As I'm approaching from the right-hand side, however, from my right-hand side, I am approaching positive infinity. So we would end up with a graph, likely something like this. Okay? Let's fill in those missing pieces. So that's how we would use limits and our vertical asymptotes to figure out the end behaviors of what these graphs look like. So I'd like you to take a look at these homework questions from page 183. There is no exit ticket for this lesson, so just go ahead and do the homework questions, and as always, reach out if you have any questions.